So engineering, the reason I decided to do the engineering is because I've just been interested in engineering since I was very young. I did work for a local aerospace engineer company for a while, and I've also worked in a garage fixing cars. So I've been around. My favourite thing on a Sunday used to be taking cars apart and looking at gearboxes and engines. So that's where I'm coming from. And I also want to say that, you know, doesn't matter whether you're a boy, girl, or whatever, you can become an engineer if it's what you want to do. And we need more engineers, particularly female engineers, I think. Okay. So the requirements you need to know are on the first screen. So what is engineering? Defining the branches of engineering, identifying there are now 15 additional disciplines of engineering. Engineering isn't just about car engines, okay, combustion engines. There's all sorts of different types of engineering. Explaining the general responsibilities of an engineer, what type of education you need, how the discipline of engineering has contributed to society. There'll be something you need to go and do on your own, some little projects that you need to do. Okay, so those things that you do, you then need to show your assessor, and obviously it'd be good to send it into the BUC. We also got the biblical perspective, looking at Genesis 6, which is Noah and the ark, but also other biblical architecture and engineering. Looking at terms that relate to engineering discipline, reverse engineering, which is very interesting, and examples of where reverse engineering is useful or has been useful in society. And then at the end, there's a little project you need to do. I've added one of my own on the end, which is to do with bridges, because I did a whole week at school, because I was in a primary school. I did a whole week of talking about bridges. So it's another thing of mine. Okay, so let's go on then. So I'm going to ask the question first. So you've got the bit where you can give an answer. What do you know about engineering? Anything at all? What comes to mind?
Anybody want to share, what do you know of engineering? When you think of engineering, what do you think of? Okay, anybody want to share? Civil engineering, some says fixing cars, others say roads, making something move, building, repairs, cars again.
Okay.
Yep. Lots of those kind of things that people think about in engineering.
Okay, right. So let's see if we can educate you further and give you some more ideas about what engineering entails or what it can be for you. Okay, so engineering, different types of engineering. Okay, biochemical, economic engineering, mathematical engineering. And being an engineer is a bit like being an artist. It's being creative. It's thinking about how I can use what I know to make something useful. So engineering is all about using your knowledge and working out problems. So engineering is...
So somebody said about maths. Do you need to have maths to be an engineer?
Well, that will be answered in a little while, but it's a very good question. Okay, so here's the answer to what engineering is. It's the study and practical application of science, economics, math, and practical knowledge to solve the issues of society. Okay, so you have to have those things to help solve the problems that we have. And then when I see some more slides, you'll see the ways in which engineering is used throughout society. Okay, now there are 4 branches of engineering. Does anybody have any thoughts about what those 4 branches of engineering might be? Just the 4 basic ones.
Okay.
We've
Anybody
mentioned
know
one
what
of
the 4 branches of engineering is? What do you think? Chemical, some says chemical, civil, electrical. Those unique nuances: civil, electrical, mechanical.
Yep.
Yep. Mostly says mechanical and electronic, civil, chemical, electrical. Yeah.
Okay.
Is that any? Yep.
Okay, so well done. So chemical engineering then we're going to have a look at first. So chemical engineering focuses on the processes applied from the sciences, so chemistry, physics, biology, microbiology, biochemistry, okay, that convert the raw materials of chemicals into more useful forms. So they take a chemical or a mix of chemicals to produce an end product, okay, or to help with a problem in some way. So chemical engineers create and manufacture material products we use every day. So one thing I can think of, when I was a child, we had a factory nearby that manufactured nylon products. So they would have gone in and looked at the chemical components of the nylon molecule, and they would have used that to convert it into something that could be used usefully for mankind. Okay. Also pharmaceuticals, so perfumes, creams, personal care products, deodorants, petrochemical, agrochemicals, biomaterials, and things like cement. Okay, cement is used in lots of things, okay, in the construction world. So you have to think about the components of what is cement. And if I put cement with cement and I put water into the mix, what is going to be the end product? Somebody had to think about that and create that product. And then there's biochemical engineering. So that's looking at biological or natural or organic materials that we have that can be used as well in the manufacture. One of the things that's used quite a lot is seaweed. Seaweed is quite a large constituent of food additives and other products. Think of natural products that come out of the soil, oil, coal, those sorts of things are biochemical because they're constituents of an organism that has been in the ground for a long time. Can use it for water purification. Foods that we eat have had to be looked at. If you go to the supermarket and you buy a packet of cereal, someone somewhere, an engineer somewhere has looked at it. One of the examples we can think of for us is Kellogg. Okay, Dr. Harvey Kellogg will have looked at corn and its constituents and decided it would make a good cereal back in the day. So it's often made from combinations of organic and laboratory made materials. Okay, so synthetic and non-synthetic materials. Electrical engineering, somebody mentioned that. What do you think might be involved in electrical engineering? Any ideas, anyone?
What do you think? Anybody? What idea, what would you include electrical engineering? Electricity, say?
Yeah.
Yes. Mobile phones?
Yes.
Televisions?
Yeah.
Some fixing cars even, some says. What else? Wiring electric cars.
Yeah.
So, which is quite a modern thing now, isn't it?
Yeah, a lot of the engineering things have developed now, and there are so many branches of engineering that have come from the basic mechanical engineering. If you think when man first started out and he decided to create a bicycle, say, that was something fairly basic. Then they decided on motor engineers from steam engines, from industrial times, and they've gradually developed everything into modern day products. So it focuses on the study of electricity, electronics, electromagnetism, okay, and all the uses of those things in testing and manufacturing. Okay, we couldn't keep our houses going without electricity. Like I said, cars need electricity these days, our phones, washing machines, okay? So all sorts of things. So it's not just somebody coming to rewire the house or put in a new light or a new socket. Okay, there are all sorts of ways it can be applied. So the role of an electrical engineer, so is the design, building and maintenance of electrical control systems, machinery and equipment. They work in transport, lighting, heating, ventilation. So think of things that keep you cool. What's the word I'm looking for?
Air conditioning.
That's it. Air conditioning. Okay, that's something that's fairly new in this country because obviously we're quite cold. We haven't needed it. Ventilation equipment, lifts, power generation, distribution. So there are all sorts of ways in which an electrical engineer can apply their knowledge and their practical use. Okay, civil engineering. Does anybody know what we mean by civil engineering? What is civil engineering?
Hey, anybody know what I mean by civil engineering? Sure, there's clever Pathfinders out there. What do you think a civil engineer does? Okay, civil engineer. Building roads? Somebody says? Building roads. Any more? Building houses?
Okay.
Civil engineering. Okay. Anybody else, guys? Oh, somebody. That's an honest answer, isn't it? Yes. Bridges. Bridges are civil engineers.
Yeah.
Building pavements, building roads, railway lines. Yes. Maintenance of structures, tunnels.
Yeah.
Yes, people are saying.
Okay, so civil engineering, again, it covers a multitude of different things that you can do. You can concentrate on being a civil engineer. So it's, like somebody said, it's design and construction and maintenance of bridges, buildings, tunnels, roads, underground utilities like water, sanitary sewers, storm sewers, natural gas, pipelines, anything that involves looking at building of constructions. And we've got 5 types. We've got construction, management, geotechnical, structural, transport, water, and architecture. Okay, and they each require their own set of knowledge to apply to them. So we've got maths, we've got mechanics, physics. So to be an engineer, you have to have some sort of creativity to help solve the problems. Okay, so if my car has gone wrong and I take it to the garage, I expect the mechanic to listen to it, to listen to me, to say what the problem is, and then they can write, okay, tick this, is it this, is it this, and to be able to solve the problem. So things like bridge construction, roads, okay, buildings, and geotechnical. Does anybody know what geotechnical means?
Ooh,
what's geotechnical?
I don't even know. That's a big word. Anybody know what geotechnical means? Because I am flabbergasted. I am blown out of the.
It's a combination of 2 words, so it should give you a clue.
Okay. Earthquakes, maybe. Somebody says earthquakes.
Okay.
I thought it would be. Geo means earth, isn't it?
Yeah.
Yes. Yes.
So anything to do with like laying pipelines. If say I was going to build a block of apartments in the middle of my town, I'd have to do a geotechnical survey. So I'd have to do boreholes to determine whether the substructure of the earth was strong enough to take my building. And also if there were any mines about, so I'd have to survey all those sorts of things. So geotechnical is all about going into the earth.
Yeah, well somebody did mention something about mining.
Yeah, mining is geotechnical. Yeah, because if you think years ago when they first started mining, the men just went down with a pickaxe and they went along a seam and they used wooden props. The company that I worked for actually, which was an aerospace company, they also built pit props as well, which were hydraulic. So we moved on from there because obviously an engineer looked at it and said, I can make that better, which is what engineers do. So that's the role of the civil engineer. Civil engineers design major transportation projects, such as, dare I say, HS2, which is a dirty word at the moment. Okay, so, but that sort of thing. People who built the Millennium Dome, things like that, that's civil engineering, okay? The maintenance of motorways, that's another dirty word at the moment in our area. In Bristol, there's supposed to be a new link road, but it's nowhere near finished and nobody knows what they're doing. That would have been civil engineers, okay? So public and private sector, roads, buildings, tunnels, dams, bridges, water supply, sewage treatment. So we'd often find also as well that the roles of the engineers overlap, Okay, so civil engineering, you'll obviously need mechanical engineering, you might need geotechnical engineering to go alongside it. So mechanical engineering, somebody mentioned before, we talked about the motor engine. Okay, what about other things that we can drive? We got when I used to enjoy engineering, I mean, engines have changed so much over the years. They're now much more efficient. They're made of lighter metals. The oils and the petroleum that go into them are much more refined now. So they run better and they're more efficient. But I still like the old engine. The combustion engine is brilliant. So it could be gas turbines, wind turbines. It's a very broad term, mechanical engineering, because there's just so much that it encompasses. So anything that moves, basically, from components to machines, even the human body. Okay, so I'll give an example of that in a minute. So here we are. We have I love that picture over there. A nice big lump of an engine. Okay, so I'm going to ask Pastor Cliff at this time if he'll please share my my clip that's got to go in there of my combustion engine, so that you can have a look, because it's quite fun.
Okay.
I tried to find something that was a bit of fun for you to watch.
So which one did you want?
Not that one, the other one.
That one, yes?
Yeah, the combustion engine, please.
Okay.
There we go. Just for fun.
Science, please!
Do the words auto mechanics make you curious? Actually, it's a cinch. A car is made up of wheels, seats, fuzzy dice, a body, and an engine. The internal combustion engine. The engine works in 4 stages. First, a valve opens and the piston lowers, letting a mixture of fuel and air into the combustion chamber. Second, as it comes up, the piston compresses the fuel-air mixture. Third, a spark from the spark plug ignites the mixture, which pushes the piston down again. Fourth, the exhaust valve opens, and as it comes up, the piston pushes the spent gases out. And the cycle
Oh, we're stuck.
starts over again. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion. The movement of the engine is transmitted to the wheels for the driver's delight.
Okay, thank you, Pastor. Whoops, where did I get to?
All right. I'm sure some people got a bit of that.
I just
apologize
thought
for the internet connection there.
Okay, it was just a bit of fun. You can go and have a look at it on the internet if you want. So the role of the mechanical engineer. So we looked about it, so I'm going to ask the question now. Can you remember, what is the role of the mechanical engineer?
Mr. Cliff, are you there with us?
Okay, and then now, can you hear me? I lost the connection.
Okay.
Can you hear me?
Yeah, I can hear you.
Okay. Sorry about that.
That's okay. So I was just asking, we'd looked at various options about engineers, but can somebody be specific about the role of a mechanical engineer? What is their role?
Okay. Can anybody hear me? What do you think? Role of the mechanical engineer is more specific. Okay, somebody says control systems, making cars,
Okay.
design engines, fixes mechanical engines, yeah, building cars or buses, building machines and make them work.
Okay,
Is
so
that
anything
any-
to do with moving components is the way I'd put it. Okay, so on a daily basis then, they confer with engineers and other personnel. Okay, so when you design a car, it's just not a mechanical engineer. Okay, you might have electrical engineers, biotechnical engineers, especially when you think about the way that a car functions these days. Okay, so it's not just the old-fashioned lump of metal that it used to be. They resolve system malfunctions, so that's fixing things. They provide technical information, perform personnel functions such as supervision of production work of technicians, technologists and other engineers. So you could have a supervisory role as a mechanical engineer. Obviously you would have to have worked as a mechanical engineer for some time before you were in that role. So they also design power producing machines. So electric generators, internal combustion engines that we just looked at, steam and gas turbines. Not so much these days, there's not so much steam power. I think steam power is underrated. I think we might have to go back to it. I love anything steam powered. Any power using machine, diggers, cranes, hoists, anything like that. And also refrigeration and air conditioning systems. And they also design other machines inside buildings, such as elevators and escalators. So it's a whole plethora, a whole great big mixture of all sorts of things that you can do if you become a mechanical engineering. So it's a bit like when you become a doctor, you choose what type of engineering you want to go for. Okay. So mechanical engineering classified into many profiled. So we got procurement engineers, sales engineers, application engineers, marketing engineers, purchasing engineers, design engineers, logistics and supply chain management, all sorts of ways that you can do things in engineering. So it's not just looking at cars. Okay, so I want us to think about using the mechanics of the human body as an engineer, and particularly thinking about prosthetic engineering, which involves the design and fitting of mechanical or robotic limbs to a human being. Now, years ago, we used to talk about the man with the wooden leg. And during the war, the Second World War, they developed legs that were easier to move. I can think of somebody there was a famous aircraft flyer called Douglas Bader. He lost his legs. In the war, but he actually carried on to fly Spitfires. So it just shows that prosthetics are a useful thing. Glass eyes, they can now take a part of the eye, like the retina, and rebuild it. They've grown ears in the lab. Okay, so it's all sorts of things that can be involved. So again, we've got, you think about how the arm moves, how your joints move. If you think how they can now give someone an arm that functions just as well as, if not even better than. In the 70s, when I was young, there was a program called, what was it called? The Bionic Man. And back then it was like bionics. What on earth are bionics? But now it's just an everyday thing. People can get arms, legs, hands. Okay, there are people who even print with 3D and make 3D hands, and they function just as well as all the fingers move. When prosthetics first came out, it was almost like a plastic bit that you just put on your arm, and it didn't do anything. But I'm going to ask Pastor now if he could share my next clip for me, please, on prosthetics.
Let's see if it works this time better. But actually, engineering is actually it's a cool career.
Absolutely. I really, really wanted to be an engineer. Never got there.
Yes. It's a very cool career that anybody can go into.
Okay.
Right. Let me quit this one off.
Yeah.
And it's that one you wanted, isn't it?
That's the one. It's just a little taste of what engineers are like who use prosthetics.
If you want to get something out of the lab and help people with disabilities, and it doesn't look like an academic publication, it looks like access, and that's what we're going for. We're giving access to people, to anybody. Control is the biggest problem affecting the clinical impact of robotic legs today. but each researcher develops their own hardware first. So everybody's testing on a different system. So when people are publishing, hey, look at this control strategy, I could do this, it's very difficult for people to replicate it because they don't have that hardware. We have created opensourceleg.com to kind of unite this fragmented field of controlled prosthetic legs. So there's a bill of materials, which explains like where to get them, so the vendor and a price. There's all the solid models, which are like how you would have it machined. The solid model files are all downloadable. There's also videos on how to go step by step through the assembly process. I mean, the website's open to anybody. We already right now have 5 collaborators who are using these and test their control strategy. So like within a very, very small amount of time, gotten a lot of interest.
Thank you, Pastor.
Oh, wow. Okay. So in other words, there's a lot of good one can do with engineering, isn't it? Like helping people to walk, helping people use their arms and their limbs again.
Yeah,
Isn't
it's
I think Jesus would be really proud for years who are actually helping people function, isn't it?
Yeah. So I want to ask a question of people. What sort of education do you think you might need to get into the area of prosthetic engineering?
Ooh, that's a good question. Mathematics, somebody says.
Yeah.
Science.
Mm-hmm. Which branch of science
What else do you think
particularly?
you need? Which branch of science? Let's take technology. Biology.
Yeah.
Branch of science, maybe. Mathematics again. Physics.
Yeah.
Maths. Mathematics. Yeah. So it's with perhaps computer science, somebody says.
Yeah. Computer science would be a good one. Yeah. Okay. So I hope everybody, when you think about engineering, that you're not just limiting engineering to an engine or a lump of metal. Engineering can be anything that you want to apply it to. You could have an interest in aerospace. You could have an interest in mechanical engineering. You could have an interest in civil engineering, building bridges, whatever it is. There's something out there in engineering, and we need more engineers. Especially in this country, and we need engineers as well within our church operating. Think of ADRA, who do a lot of work across the world for developing countries. They would need engineers too to help construct buildings, to help people with foods, even development of foods. Okay, so there's all sorts of ways that we can use engineering. Okay, so. I also mentioned other things you can go into. Here's one for you: a sales engineer. Okay, so once you've got your background in engineering, you could become someone who sells the product to a person or a country or for a government. Okay, so you provide not just selling, you provide advice and support. So you need to have done the engineering before you get into those things, because obviously it's useful if you're sending a product to somebody to be able to explain the technical details of that product. Applications engineers. So an application then uses customer input and sales information to design or to redesign and develop and test new improved products. You know, when the latest thing with Hoovers on the telly, new improved Hoover. It's got more suction power, the engine is more compact, it picks up finer dust, that sort of thing. So they're the people that take feedback from other people about products and able to then go on and make a better product. Marketing engineers, okay, so they're slightly different from the sales engineer. They're not actually involved in the selling, but the marketing. And they apply technical knowledge as well to sales and marketing campaigns. They help sales teams and external clients to promote the product, and obviously to get more sales and for more people to know and understand about the product. Procurement engineers, they oversee purchasing of technical goods and services for industrial operations. So there's sort of subgroups within those groups. Right. One of the questions is to identify and define at least 15 additional disciplines of engineering. I've given you a link there to Wikipedia. If you go to Wikipedia, there's a whole great big page to find out about all the different additional disciplines of engineering. So I'm going to ask the question, can you identify another discipline of engineering beside those ones that we have talked about? Any ideas, guys?
Okay, anybody else? Structural engineering?
Okay.
Any other disciplines that you think? Additional disciplines of engineering.
Think about the
Can you- oh,
application of engineering. Where do we use it in society?
yes. Environmental engineering.
Okay.
It says,
Okay, good.
I think. Computers,
Yeah.
hydro, economic, disciplined engineering. Now that's an interesting one. Security.
Okay.
Yes, definitely
Because we've got
security.
biosecurity and computer security problems. Yes.
Aerospace, biomedical, agricultural engineering, domestic. Suppose that's all your, making it easy for the wife to to do everything very nice without having to work too hard, isn't it? Domestic engineer. My wife would like to have a domestic engineer, come and sort out her home.
Okay.
It's optical engineering, right?
Yeah.
Oh, yes, optical.
Okay, so there are all sorts of things. I'm just going to go to my next slide, okay, because we talked about them and different ways that it's used in the field. So we have got aerospace, okay, so it could be commercial or private airlines, things like the Boeing, which is one of the biggest corporations.
Mm-hmm.
The company that I worked for actually made the landing gear for the Boeings. Optical, someone said.
Okay.
Traffic engineering, okay, looking at systems to operate traffic through a town or a city maybe. Process engineering, which we talked about, which is looking at how things can be developed. Computer engineers, geotechnical, environmental, someone mentioned nuclear, acoustical, okay, to do with sound, structural, biological, textile engineers, okay, developing new textiles using that, maybe that biochemistry, that biochemical, or even natural products. Industrial, materials engineers, transport, energy engineers, okay, all sorts of energies that you can have, renewable energies or natural energies, power engineering. So there are all sorts of different ways in which engineering branches off, so you can choose which your interest is. So it's a whole great big thing. So aerospace, we said, environmental, and an engineer, okay, asks the question.
Somebody said meteorological.
Yeah, okay, to do with the weather. Yeah, that's another branch.
Yeah.
There's all sorts of branches out there. So say an engineer has to have an inquiring mind, asking questions. They have to imagine what the product is going to do, what it's going to do like. They have to plan, so making diagrams. So your maths, technical engineering. When I was at school, I did technical engineering for a year. Then you have to create that thing and then test it and improve it. So the whole thing just keeps going round. So Mr. Dyson has lots of engineers and his plant who were constantly improving his hoovers. So the general responsibilities, okay, general responsibilities of an engineer. What might be the general responsibilities of an engineer?
While everybody's thinking, I would say probably a lot of dreaming. Because that would be great, isn't it? To dream,
Yeah, well,
think of
well,
looking
God
at
gave us
something
our-
and says,
Yeah.
Exactly, creativity.
Yeah.
Yes. What would you
God
think is
gave
the
us the-
responsibilities?
God gave
Yes,
us our
to create.
intellect in order to use it for these reasons.
That's right. To create.
Yeah.
Yes. And I
Okay.
think it is, and it's the sense of being what you said, the sense of being you know, exploring and being not the word, what, not nosy, what, inquisitive, isn't it?
Yeah,
Have an
inquisitive. Yeah.
inquisitive mind.
Yeah.
Yes.
Okay, so let's have a look then.
Test and improve.
Yeah. Okay. So an engineer is a highly regarded professional. So
Solving
would you like to
problems.
be a highly regarded professional? Okay. Focusing on solving problems for society, but on a larger scale, because you might have a small problem, but engineers think big, okay? So using your in-depth knowledge to help, using your science, your maths, critical thinking, and putting that critical thinking and applying it to the practical use for benefits for everyone. And developing, okay? So you might,
You
yes,
think a pastor, you think a pastor is an, you think a pastor is an engineer, you know, thinking of a different sermon every
Yeah.
week.
A
You know.
biblical engineer.
A biblical engineer.
Yeah.
And that's what we can call ourselves. We are
New
biblical
title,
engineers.
a biblical engineer. Okay, so it's all about looking at, now, when I talked just now about the development of the engine and the car, okay? Cars, when I was a child, were big, heavy old lumps of metal that lasted for years. Now, if you think in motor racing, how the body is put together, it has to be lighter and more streamlined. And that's what engineers do. They look at something and they think, how can we make it better? So we did sort of mention it. So what type of education is required for a career in engineering? So where would you have to be in your education in order to become an engineer?
All right. Anybody else? Anybody share what kind of education you need to have? You think? Right? I'm sure some would say is if we have at least have an A level, is it?
Okay.
Mathematics,
Yep.
BA, MA, PA,
Yep.
certain sciences.
Yep.
Yep.
Okay. So let's have a look, because we did
You
mention
must
those.
have your GCSEs.
Okay, that's a beginner.
Least.
To work as a mechanic, you need City and Guilds. City and Guild certificates. That's for being a motor engineer working in a garage. Okay. So what qualifications will we need to be an engineer? And it would depend on the branch of engineering. Are we thinking physics, maths, okay, human biology, chemistry, okay, thinking about genomes, genetic engineering. Okay, it depends what branch of engineering you're going into, but the sciences and maths are the start of your engineering journey. And then depending on where you want to go, you would choose chemistry or genetics or biology as your next step. So at a minimum, it's an undergraduate degree in order to become a successful path as an engineer in any field. Okay, so all those bits you do at the bottom are your building blocks. Okay, so then it's leading to that undergraduate degree, because let's face it, out there, everyone is after the best job. Okay, so you need the best qualification you can get to be the best in your field. Okay, depending on what you want to do. But again, sciences, maths, okay, there's a lot of coursework it's in it, there's no denying that. But once you set your mind to it, if you have an interest in those things, the rest of it will come. So life sciences as well, if you're thinking about the prosthetic engineer, the life sciences and biology would be your way to go. Okay, so now I'm going to ask the question. I want you to think, how has the discipline of engineering contributed to society? What ways has it helped society?
Okay. What do you think, guys? How is it now? You sure you got lots of answers here. What do you think engineering has contributed to society? Any examples, perhaps? It helped
Yes, that would be
society
good.
adapt. It helped make work easier. Any examples, perhaps, that you can see, perhaps in your own country, where you think engineering has helped
I
society?
did give a couple of ideas earlier, if you were listening. So I'm just
Yeah.
testing now to make sure you're listening to what's going on and taking it in.
Help with the missing body parts.
Yeah.
Improve transport, safer structures, food, water systems, medicines are some. Definitely the Dyson, the Hoover is a good one, in terms of help with. Yes, I think the washing machine, the fridge, all those things, isn't it?
Yeah. So
advanced technology, safety and advanced technology, improve lifestyle. In other words, it helped make work less strenuous. Somebody said.
Okay, brilliant. So let's have a look. Okay, bridges. Okay, does anybody know about different types of bridges?
Yes, bridges.
Yep. Any different types of bridges you can think of?
Any different type of bridges you can think of, guys? Think of
Okay,
any examples of great bridges, but like London Bridge.
This one is not far from where I live, and it was actually designed and built by one of my
Where is that?
my most favorite engineers. It's the Clifton Suspension Bridge.
Okay.
It goes across the gorge of the river that comes up to Gloucester, comes across the Avon.
Okay.
What about road bridges? They're actually what we call a beam bridge. Beam bridges have been around since mankind. You might see them across places in Devon might have beam bridges that are built with big flagstones. Okay, but the modern beam bridge is your motorway bridge. Okay, then we've got this is another local bridge. This is actually the second Severn crossing down the road again in Bristol. This is a so you've forgot what it is again. It is a cable stayed bridge. I had to think for a minute. It's called a cable stayed bridge because you can see it's not very clear, but if you look at the way you can see the triangular bits coming down from the concrete stays, they're actually cables which are keeping it stable. So it's a cable stayed bridge. Okay, then we've got this one which is in Edinburgh. It's the fourth bridge.
Yes.
It's called a truss bridge.
Okay.
That one's a truss bridge. It's built in bits that are brought in and then put together. So they're prefabricated and brought to
there's
site.
a very interesting story I share about that bridge.
Okay.
In terms of how it's on the cantilever. It's called the cantilever effect that bridge is built on. In other words, the two sides support the middle one. The middle one is pretty much hanging in the air almost.
Yeah.
Thinking about it, because the two supports the other, the one in the middle.
Yeah, it's actually a combination bridge, that one. I call it a combination because it's got an arch. And here's an arch bridge, another famous arch bridge. This is in Iron Bridge in Shropshire. Another famous bridge built by an engineer a good 100 or so years ago, about the same time as the Clifton Suspension Bridge. And you mentioned Tower Bridge. Tower Bridge looks old, but it wasn't built all that long ago. So yeah, those are different types of bridges for you to think about. And I like bridges again, and I find them interesting. I like any architecture and engineering, but the different types of bridges and their purposes and why they were built the way they were built. Because what happened was with the suspension bridge, and at that time, engineers were asked to put in a bid to build the bridges. So whoever won the contract built the bridge. Okay, transport. We talked about civil engineering. So that could be rail networks, motorways, roads, cars, buses, trams, any form of transport. Aerospace. Okay, commercial planes that we fly around in, planes that are used by the forces, helicopters, space shuttles, space rockets, all those sorts of things. So they use different types of engineering to keep them going, so that even the parts of an aircraft can be part of a different genre of engineering.
Mm-hmm.
And now my clicker stopped working. Naughty clicker. Okay, also, what about food and nutrition? Okay, is
Yes.
engineering involved in food and nutrition? What form of engineering do you think might be used for food and nutrition?
What do you think, guys? What do you think is?
Would a mechanical engineer be
food?
involved, or?
Somebody says a chemical engineer, genetic engineering.
Yeah.
Genetic, chemical engineering, yes.
Okay, we had a little bit a good few years ago about all the E numbers that went into foods for preservatives. Okay, but they've now developed better ways for our food. Okay, so food science and technology, farming as well. Thinking of ways. Does anybody ever watch the country file? Okay, it's quite interesting because they often talk about farming techniques and the way that engineers now are looking into different ways of farming foods. Okay, we've got chemistry, so combinations of tastes in foods, food packaging. Okay, so engineers designing packaging, engineers designing the machinery to make the packaging, the machinery to process the foods. Okay, there's lots of different ways that it can be used. Okay, so this is when you're going to have to go away and do. So on your own or with a group, you've got to develop a chart board. So it's a bit like a spidergram or a blue sky thinking, we call it now, not the other word. So finding an engineer, okay, there are lots of engineers out. It'd be nice if we could find some female engineers. I did say that there are quite a few. If you look in and look for lady engineers, female engineers, they were around in the early years. There was one lady back in the 1800s called Nora Stanton Barney. She was actually a civil engineer and architect. So even back then, but in those days you had to have money and a husband to support you. But these days, ladies, girls, we don't need that. We just need to want to do those things, become an engineer, change things. Okay, so you've got to think of an engineer, consider the type of engineering that the person's done, what they've developed. You might have an interest in a certain type of engineering, so find an engineer that fits what you're interested in. We want dates, places, times, what it is that they did. And say, what about famous women engineers? There are lots out there, even modern day, involved in aerospace, things like NASA, so developing things for space travel. Okay, so here's mine. And earlier we looked at one of his bridges, Isambard, Kingdom, Brunel.
Oh, yes.
So he was quite famous. He was famous for his stovepipe hat and his cigar. He actually died quite young, unfortunately. But he developed quite a few engineering products, including the Great Western Railway, which runs through my area. Okay, so I had to look at him and I brought out some pointers. I'm sorry, it's not in a board, but I looked at it. I could make a board of it. I could make a date and timeline. So I've thought about when he was born, where he was born, his schooling, where he worked. He worked on the Thames Tunnel with his father, who was also an engineer. Unfortunately, his father drowned when the roof collapsed in 1827. When he was recovered, he entered and won a competition to design the bridge over the Avon, which is the Clifton Suspension Bridge. Who he married, he had children, what he was known for. He was the chief engineer of the Great Western Railway, as I said. He designed the railway line between London and Bristol, and the Templemead Station in Bristol, and Paddington Station in London, okay, which are good engineering structures. So it's also architecture as well. And he designed ships as well, the SS Great Western and the SS Great Britain, which is in dock at Bristol at the moment. And I said, when he died, where he died, where he's buried. And, you know, his legacy still goes on. It's not just, it didn't stop. Okay. So part of being an engineer is looking at what people have done before you. Okay. And each engineer then can build on. So something to think about. So think about what branch of engineering you'd like to do. Find an engineer and off you go. So in the Bible then, particularly Genesis 6, we need to look at Noah. Okay, Noah was an engineer. He didn't think he was. We're all engineers in some way. We all put up our tents, hopefully. We light fires, so we have to know about the principle of building a fire. That's sort of engineering. Okay, so Genesis 6. We don't think of the Bible as having engineering projects, but there were quite a few in there. And one of the first ones we're looking at is Genesis 6, which is Noah and the ark. God was quite specific about how big the ark would be. So God was the engineer who initiated, okay? Then we had Noah, who was actually the project engineer. So he went and made it. And then obviously he had his family who equipped it with him, and the animals went in. So the Bible has lots of engineering places. So think about the design of the ark. God is the great engineer. He designed the whole of the world. He designed the way in which a tree grows from a seed. He designed the way in which trees are planted. So he was a great engineer. So he's given us some places in the Bible. Okay. And also Noah and his family then had to become marine engineers because they had to sail the ark. They had to become zoological engineers, if you like, because they had to cope with all the animals in the ark. So again, Noah had knowledge of, at the end, of different branches of engineering. What else is there? Now, you've been asked to identify 4 specific biblical engineering marvels that illustrate the art and importance of engineering. Can anybody think of any that are there? Any biblical engineering that went on?
Okay, guys, any idea that you have, that you think of? Well, somebody said, was Joseph an engineer because he was a carpenter?
I suppose so, because he would have had to, in those days, he would have had to make a plan in his head,
yes,
and work to a specific details. I mean, if he was making a chair for someone, if you're making a chair, say you're making a throne for the Queen, it has to be a specific size and shape, made of a specific wood. So I suppose that is, carpentry is engineering, because it's creating and building an end product. Yeah.
Okay. Somebody suggesting the sanctuary, Tower of Babel.
Okay.
The Tower of Babel, Solomon's temple.
Yeah.
Yes.
Okay, so we got
Babylon in terms of the walls of the Hanging Gardens of Babylon.
Yeah. Okay. They would have had to be
Jericho.
Yeah. So we've got the Tower of Babel, Solomon's temple, the sanctuary, somebody said, and the walls of Jerusalem. Okay, all those things had to be thought about. They weren't just somebody came along and said, let's throw a load of bricks up. Okay, if you're going to build a house, you don't just say, right, well, I'm going to use this piece of land, I'm going to make a hole here, I'm going to throw my bricks on. You have to have a plan. You have to be creative. Engineers have got to have a creative process. I mean, with the Tower of Babel, we don't know exactly what it looked like. We've only got the biblical description, but they would have had to have some sort of plan for a tower that tall. So yeah, God put engineering into place in a lot of places. So we got some terms that relate to engineering discipline. So I'm going to give
Nebuchadnezzar's statue.
Yes, that's a thought. All sorts of things. Okay, so coming back to the modern world then, thinking about different branches. Today, a lot of CAD is used, computer-aided design, and the software and programs now that people use are revolutionary. When I think back to, well, when I was your age, I didn't we didn't have computers. We had a calculator if we were lucky. So yeah, computer-aided design now is just wonderful. I mean, you can do 3D models of buildings, of cars. They're regularly used by architects, designers, inventors, and mechanics. Okay, we can put pieces together on a. I mean, we saw that picture of the combustion engine earlier. You could, I mean, now on computers, you can like fly in the pistons, you can fly in the conrods, you can put in the camshaft, etc. By using your computer.
Yes.
Simulation. So we said CAD, simulation, by the word that it says, it allows engineers to justify selected equipment necessary to address the projects in the early stages of development, such as software, computer machinery. So simulation is whereby years ago, it used to be just a drawing and maybe a little cardboard model, but I say now you can use a computer to aid your design. So that's simulation. It's before you actually even start to produce what it is you're going to produce. So that's simulation. Okay, rendering. That's the ability to take it from 2D and 3D and your computer aided design, and then allowing the engineer to quickly develop 3D scenes. You know, now on your phone now you can produce a photograph and your friends can move their phone around and look at it in 3D. So it's the same sort of thing. So from years ago when I did technical drawing, it was just a flat piece of paper and you put your dimensions on. You said if it's the front elevation or the side elevation, and that's what you produced. Then we got steady state. So it can have multiple meanings depending on the engineering discipline in question. What else have we got now? So electrical engineering is the ability for a machine powered by electricity to regain original powered state. And mechanical engineering is the ability to regain stability after a force is applied. Okay, so the electrical is the power, the mechanical is the actual way in which the thing works. So think of the pistons in the valves. Okay. And then we have a word constraint. It's all about setting limitations. What is the constraint? Can I make this product? Can I produce this new engine? How can I do it? What are my constraints? Costs, safety factors, materials, how long is it going to take to make it? Like I put one there, bridges. So when they thought about the suspension bridge, what loading can I put on my bridge? What can it take? If I have, like the new bridge in London, is it the walking bridge that they have? When they first put that together, it used to have a whole lot of sway in it, so they had to redo it. So sometimes, even though the product's made, it has to be tested. Another thing is one of the bridges in America, can't remember what it was it before the Golden Gate Bridge? They had a bridge in America somewhere, and then they had an earthquake, but the bridge, because the earthquake shook it, it twisted and bent, and it was no good. So they have to think about those things depending where you live. So that's our geotechnical as well in there. Reverse engineering is fun. I used to like doing reverse engineering when I was a child, taking apart a clock or a piece of machinery. So reverse engineering is all about learning from other people's products. So it's about the development. So it might have been somebody made a product years ago, but it wasn't manufactured. But now we thought of a use for it. So we take it apart, we deconstruct it in order to learn how it works and how we can make it better. So the product is there, but we're taking it apart. So that's reverse engineering. So now we've got the product, we take it apart, we look at it, and then we make something new from it. Yeah, are we okay with that? Reverse engineering. It's also called back engineering. It's a process by which a lot of man-made products are looked at. They're deconstructed in their designs, architecture. So I talked about the bridge that flipped around in the earthquake. So they would have deconstructed that design and built something better. It's all about research, okay? And it's often used when the component or its spare parts are no longer available. So say I've got a 1930s Morris Minor or a car like that, I can no longer get one of its components. So I have to have the old one in order for somebody to re-engineer a new part for me. Years ago, when we took engines apart, sometimes where the piston had been going up and down the cylinder head would wear. And so we had to send that away to be re-engineered. So it's that sort of process. So we want quick recovery. We need to learn about the application and preparation of the initial model. So it's all about looking at those things, taking it apart and making it better. So this was just an example. They wanted something, a system valve, which is used to control flow rates in engines. It could be a plumbing piece. They didn't have the part, so you had to take it apart, and it may be that they wanted a small washer or a rivet. Okay, so you have to take it apart. It could be air conditioning, refrigeration, all those things that use valves to control the flow unit of water or heat. And now we're sort of coming to time, so I'm going to tell you about the fun bit now. Okay, you've done all the learning, you've done all the listening. And Pastor, I can't hear you.
Before we go there, Auntie Pam, maybe when you said about reverse engineering, we're not encouraging anybody to go to their parents' Hoover and start taking it apart.
No, please don't do that. But you can research online, okay? You can think about it. You might go to a junk shop and find a piece and play with that, okay? I used to like taking engines apart, but I'm not doing that now. So, guys, we come to the fun bit now. You're going to have to do something. You've been asked as one of the things to do a paper airplane, which is good fun because you can do all sorts of things. I like making wing flaps, try and make aerofoils on it. I put a tail on it. Sometimes I put a pointed nose. So it's a bit like Concorde, if anyone knows about Concorde. So make a plane, make different designs of a paper plane to see which one flies the best, which has got the best aerodynamic. Another assignment is to make a compass. Okay, there are various ways of making a compass. Again, if you do these things, take photographs of it, make sure you keep the project so that it can be seen, and you're going to be sending them in, please. Also, one of them asks you to design a dam using lolly sticks and bits and pieces, but I'm asking for a further challenge.
Wow.
Okay? Bridges, all right? So those of you who want to do something more extensive, I'm saying look at the different types of bridges, suspension bridge, arch bridges, etc. Design and make a bridge using your cardboard roll, choose bits of cardboard packing. I want you to make a bridge and then test to see how strong your bridge is. Are the materials you've used adequate? Okay, I did a whole week with the kids at school and they all built different bridges, and then I went along with kitchen weights that you can buy and put them on, or don't start with a bag of sugar, that might be too much, but see how many different weights you can put on it. Or does a car go across it? Is it straight enough? Is there, yeah. And if you're going to do these things, what have you got to remember? Do them safely. Make sure whatever you use is appropriate materials, okay? But there are things you can use around the home. But most of all, have fun. And please submit your all and practical work to your assessor. And we'd like to see your photos. I'd love to see anything you've made. I'm just so interested to see what you can take, and send them to Diane@adventist.uk. And that's the end of my presentation. I hope you've enjoyed it, and it's been fun to think about. And I want you to think about being an engineer. That's your task.